In the last couple of videos, we discussed the concepts of ownership and borrowing. To better understand them, let's explore how they actually work at runtime. So here you can see that I have commented out a part of our code. I've left the reading from the standard input, and after that I code two functions. The borrow string, and I pass a reference to this one, and the own string, and I move my string into it. So again, the borrow string just borrows our string and prints it, and the own string takes ownership of the string. So let's see how this looks like with our good old friend, the debugger. Okay, every time we build a project with cargo, it will put the binaries in a folder called target, and in this folder there is a folder called debug. So if we go to target/debug, we can see that we have our marscalc binary here, and we can just run the marscalc. It will wait for some input, and then it will print it. Okay, now let's open that in our debugger. So now we want to put a breakpoint on our borrow string function and a breakpoint on our own string function. And we would also like to put a breakpoint on before we call them, which is on line 8. So we put a breakpoint on main.rs line 8. Okay, we have our breakpoints. Let's run our program. First, it actually waits for some user input, so we can type 1, 2, 3, 4, 5. That's done. So we are in the main function. First, let's actually explore how the string is represented in our function. So if we inspect our locals, we see that we have one local variable, which is the input, and it is represented with this quite complicated structure. As you remember, the string is just a pointer to the heap and some extra metadata. So for example, it stores the length of the string directly on the stack. So if we were to ask about the length of the string, it can tell us immediately. It won't have to go and read from the heap. Also, it has a pointer, which is a pointer to the heap, and at this address is where the actual bytes of the string live. And the debugger is nice enough to actually show us what is there. And we can see our input of 1, 2, 3, 4, 5 and the new line at the end. This is how the string is represented on the stack. Okay, now we can jump to our borrow string function. And in the borrow string function, if we inspect the arguments, we see that we just have an address for our S. The S that is just borrowing the string is a pointer. That's an important thing to remember. A reference is just a pointer, nothing fancier. At runtime, it has no idea about all the rules about references, like all of this fancy functionality is enforced by the compiler at compile time, but we pay no price for all of this at runtime. If we actually dereference this pointer, we can see that it points to our original string. So a reference is just a pointer. That's the important thing to remember here. Now we can jump to the other function, which is the own string function. So if we inspect our arguments here, we see that now we actually have the whole structure again in this function. So because the string ownership was moved to this function, the entire string was physically moved. So the value on the heap is still the same. This value was not touched, but this whole data structure with the metadata was physically relocated in memory into the stack frame of this function. So now this function does not hold a pointer to the string structure, it actually owns the string structure. And when this value goes out of scope, it will just deallocate the pointer that it holds to the heap. So this is an important difference to understand. When we pass references, that just means that we create pointers to data that we already have, but when we actually pass ownership, that means that we're moving the data from one place to another. So that's pretty much how things work, and if we continue, our program exits successfully and prints our number.